forward button is always enabled, even for sensitive internal corporate documents. Now, obviously, if email is really going to be a valuable and useful technology, we need to have the ability to have an appropriate policy that indicates whether email can be forwarded or not. So we're going to have an X no forward header. Okay, so email will work just like normal, except if there's an X no forward header and it's set to 1, then an email client should not allow the forward button to be used. Well, Microsoft has a slightly more complicated approach to this, which involves actual encryption in some cases. Whereas in this analogy, it's important to note that there's no encryption going on, because you don't actually want to re-engineer the protocol. You just want to say there's a behavior, and we demand that implementations exhibit this behavior. And so in the analogy, they're saying any email software that's willing to forward email that contains a no forward header is naughty and shouldn't exist. And we need a regulation saying that all email software authors have an obligation to look for and obey the X no forward header so that emails won't be leaked to journalists. So they actually persuaded the communications regulator to enforce the equivalent thing with regard to the open, unencrypted ATSC digital TV standard. This irritated us very much. So we took them to court, and we challenged them in court. Unfortunately, our lawyers, being very clever and skillful lawyers, they didn't actually say in court that this was a bad idea or a stupid idea or that it was the wrong decision. They adopted the much more successful legal strategy of saying that the communications regulator didn't have the authority to pass the rule. And that worked. And we got the rule thrown out. But the trouble is that the court didn't actually say that it was a bad idea, right? The court said, oh, well, you didn't have the proper authority to do that. You need to get the authority from Congress. So, of course, Congress is still very interested in giving them that authority, and we still have this political issue, because the regulation could be reinstated at any moment if Congress were persuaded to give the authority back to them. So we won a very nice victory, but it's potentially a very temporary victory. So as I mentioned earlier, DVB has been a really nice example, because here we have a complete suite of DTV standards that basically don't have any built-in DRM facilities historically. And that's even true for pay TV, which is actually really surprising to people in the US. That is to say, if you're using a pay TV service in Europe that supports the common interface, and not all services do, but some services do, then you have a documented standard way to get your pay TV that you still have to pay for, at least in principle. And you pay for this and it comes into your house and there's a particular point where it actually gets decrypted and then you've received it. And then you've got an MPEG stream. And this is true for both cable pay TV and for satellite pay TV, if you have systems that use common interface. So you get a lot of cool stuff as a result of this. For example, open source PVRs on computers. You have MythTV, you have VDR, you have the ability to have a card in your computer that's lawfully decrypting pay TV service that you paid for and giving you the ability to do all kinds of stuff with the MPEGs afterward. In fact, a lot more sophisticated than the things that the commercial PVRs allow you to do. Also, having this open standard gives you an example. When someone says, we need DRM in everything, DRM is the normal way to do things, you can say, well, we've got the DVB protocol suite, and people are actually using it, and they're actually putting TV out there, and it doesn't do DRM, and the sky isn't falling. So what's the problem? Unfortunately, DVB is now working very hard to reverse this situation, to make it exactly the opposite, to create some of the most restrictive DRM for digital TV in the entire world. And they're doing three things that we worked on and tried to stop and did not stop in the standards committees. And I'm going to talk briefly about each of these three things. And then I'm going to ask if anyone has any ideas for how to stop them. Because to my regret, and predictably, we did not manage to stop them in the standards committees, and they're still going forward in the standards committees. And there are still a lot of people in European TV industry and entertainment industry and American entertainment industry, who are very interested in seeing all of these things implemented in practice in Europe. So the three things are a DRM system called CPCM. I'm sorry for the acronyms. There are a lot of acronyms. I don't know what to do about that. I'm actually sparing you a lot of acronyms, but I'm still throwing a lot of acronyms at you. The second thing is a revision of the common scrambling algorithm that's associated with the revision of the common interface. And I mentioned the common interface earlier. And a number of you, if you're subscribers to pay TV services, may actually be using the common interface now. But the common interface is being revised. There's a new version being created with a lot of integrated restrictions that simply don't exist in the current version. And finally, there's a specification being developed for a broadcast flag, almost exactly parallel to the US broadcast flag, that would apply through regulatory measures to free over-the-air DVB-T broadcast. So CPCM is a really modern DRM system. It hasn't been implemented, it's only a specification. This specification is actually publicly available, although it's still not done. It's called the DVB CPCM Blue Book. It's very dry reading. One of the really significant things that it does is specify a really large number of extremely specific restrictions that can be imposed on users. And I mean really specific. So one of the real obsessions that the Motion Picture Association of America has had recently is geographic control and proximity control, and trying to figure out where devices are in physical space. I've thought of this as reimposing geography on the internet, because you go to these meetings and people talk for hours and hours about, well, this device has network connectivity to that device, but that doesn't mean they're in the same room. We've got to have a way to call a function that will tell us if these devices are in the same room or not, so that we can have a policy that treats devices differently when they're in the same room and when they're not in the same room. And people are talking for hours and hours about specific ideas about how to put geography back into the internet. Because, you know, we have devices, people get excited because they say, we don't have to rely on geography. We can do things remotely. And the view of the CPCM system is that being able to do things remotely and being able to do things over a network and being able to do things in another building is a privilege, not a right. And there ought to be a way to express policy about it, to decide whether you're allowed to do it, to say specifically whether you're allowed to do it, and to what extent and in what circumstances. So we have this huge list of possible policies that can be imposed, and it's very long. And it's essentially a complete laundry list of things that MPAA would like to be able to assert as policy in a modern DRM system. Also, the purpose of the CPCM system, as many participants at DVB have said, is to be used with the common interface, to be mandatory for use with the common interface in Common Interface version 2. So when the common interface is updated, when it's replaced, all devices that want to get content, that want to get MPEG streams out of the common interface, are going to be expected to implement this or an equivalent. Let me just give you a couple of quick examples. This is a tiny subset of the huge list of policies that are in CPCM. You have geographic area, which is presumably a particular polygon on the surface of the Earth, presumably defined with trusted GPS. So you have tamper-resistant GPS inside a particular device. There are other ways of doing this too. If you want to invent another one, MPAA will be proud of you, because they want to give implementers choice and flexibility in how they enforce restrictions. So you can imagine drawing a polygon and saying, you know, from this GPS point to that GPS point to that GPS point, and if you're inside that space, then you're in a geographic area and you're authorized to view this, or potentially authorized to copy this. Then we have local environment. This is if you can prove that you're physically near another device, you may, at the option of the copyright holder, be authorized to copy between those devices. And they can define what verifiably physically near or in proximity means. And again, they have a whole list of ways of testing this, and if you can come up with another one, again, the MPAA will be grateful because you'll be giving choice and flexibility to the implementers. But we have things like cryptographic pings. So you ping someone and they sign the response cryptographically, and then you measure the latency in milliseconds, and if it's more than so many milliseconds, then you haven't proven that you're on the same physical local segment. And they have a whole lot of things that go on from there. One of the really silly ones that they're thinking of using is IP time to live. Yeah. I think someone will talk them out of that before they implement it, unfortunately. And then there's a concept of authorized domain that's very offensive to some people because it arose out of the idea of letting devices determine in their binary kind of way whether they're part of a particular household and whether they're part of the same household or not. This means that you have to make a mathematical model of what constitutes a household, and that's kind of offensive to a lot of people. Obviously, you could look at it another way and say this is just an arbitrary set of devices that are allowed to share content. If you say that they're mathematically modeling your household and deciding whether your household is mathematically acceptable or not, then that kind of annoys people. If you say, this is the set of devices that constitute the AD, then that's somehow not disturbing in the same way. But it arose from a household modeling idea, and there's a hypothetical algorithm called the authorized domain management algorithm that determines if devices have historically been close enough to one another to be legitimately referred to as constituting a household. We don't know what the algorithm is. They say that's a compliance issue. Some other entity has to actually write the algorithm. We're just going to create the vocabulary that they would use, the concepts that they would use. And so obviously there's a whole Venn diagram. It's very elegant, right? You can have GA plus LE or GA plus AD or any combination of these plus any number of other things. Expiration dates, numerical copy counts, really fine-grained control. And again, the purpose of this is, I'm sorry. I did page down here and not there. Sorry, I should have had this slide up while I was talking about those three things. So we have the geographic area, the local environment, and the authorized domain. And many, many other things. All right, so the purpose of this, again, is for the common interface. The common interface is an open interface, an unencrypted interface that's used. I think something's gone wrong here, so I think I could use some help here once again. That may be why it didn't page down. Thank you. So the common interface is an open interface, as I said, an unencrypted interface that's used in conjunction with pay-TV in the DVB system, used in conjunction with conditional access programming, so that you can have a proprietary means of determining whether you paid for something, and then an open set of devices that can actually receive the programming after you've paid for it. This is a pretty cool idea. There's actually European legislation that requires some manufacturers to support the common interface on the grounds that it's very pro-competitive, and I'll talk a little bit about that later on. So again, it's not encrypted right now. If you pay for the programming, it gets decrypted, and then you can do what you want with it. People at DVB think this is horrible. They can't believe that anyone actually would have designed it that way, even though it was they who designed it. But they designed it back in the pre-DRM era, when we didn't know that these rights have to be enforced by technology. And so the obvious conclusion is that when they do the new version, they're going to have some intellectual property, trade secrecy, patents, and other things in the new version of their common scrambling algorithm. And they're going to license the devices that are able to interoperate with the new common interface. By default, they're going to forbid all recording. And that's the default state that they're going to start from. It's a bit different from what we have now, if any of you are using common interface cards in your PCs. And then later on, they're going to negotiate and figure out a way to enable some recording using a DRM system or policy expression system similar to or identical with CPCM. Okay, so why does the industry think it's okay to do this? First of all, they say, well, it's their content, so they're entitled to do it. Okay, even if they're not entitled to do it, they can. Because as a practical matter, if you have a particular kind of conditional access system that doesn't do these restrictions, that doesn't have the CPCM rules and policies and expiring recordings and whatever, then they can refuse to license their Hollywood movies or their sporting events or whatever for distribution via that system.